Today we're going to talk about families of elements and why certain elements are said to be in a family, and also how we arrange the columns in the periodic table. Now, let's start out pretty easy here. I'm going to do oxygen. So that's going to be 1s2, 2s2, 2p4. Okay. So there's oxygen. 1s2, 2s2, 2p4. Now, when I do the orbital notation, also easy. 1s2, up, down, 2s2, up, down, 1, 2, 3 lines for the p. 2p is going to be up, 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 down, up, 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 down. Okay, so that is the orbital notation for oxygen. I'm going to show you something there. The highest big number that we see is we have the first energy level and the second energy level. So everything that's on the second energy level is farthest away from the nucleus because oxygen doesn't have anything up in the third energy level or the fourth energy level. It goes all the way up to the seventh energy level. There are some 7s elements there. So you see here that oxygen has 1, 2, 3, 4, 5, 6 electrons in its outer energy level. So we would say that oxygen has 6 valence electrons. And those valence electrons are going to be the ones that govern how it makes bonds, how it behaves, how many electrons, if it's making an ionic compound, it wants to gain or lose. Now, let's talk about sulfur. So sulfur is going to be 1s2, 2s2, 2p6, 3s2, 3p4. So its orbital notation is going to be up, down, 1s2, 2s2, up, down, 1, 2, 3, 2p. Now remember, when we get to 2p, up, 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 down, 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 3s2, up, down, 3p4, up, 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 down. Okay, so there's sulfur, and there's 1s, 2s, 2p, whoops, 1s2, 2s2, 2p6, 3s2, 3p4. And so now sulfur is bigger than oxygen. And so you'll notice that the biggest number it has is 3. But it has 2 plus 4 is 6. It also has 6 valence electrons. And so, as we begin talking about how these elements behave, you're going to find out that oxygen and sulfur, even though they don't really resemble each other very much, they are going to behave pretty much the same. Like, for instance, oxygen, since it has 6 valence electrons, is likely to want to gain 2 when it pairs with a metal and become a -2. Sulfur, the same way. When it's making a covalent bond, oxygen is likely to want to have 2 bonds. It can either bond to 2 different things or bond to one thing twice. Sulfur, same way. The difference is that you'll notice in between oxygen and sulfur. I mean, oxygen's a gas and sulfur is generally a solid at room temperature. It's yellow, smells bad. Oxygen, colorless, odorless gas. The differences are just going to be the differences that you find of the forces that are governing the fact that this one's in the 2p and this one's in the 3p. And so you'll find that